Dear brothers and sisters, every leaf on Earth hides a secret, a machine that has powered life for billions of years through photosynthesis. But in just about a century and a half of industrialization, humanity has broken that balance. Over 37 billion tons of carbon dioxide now flood our skies every year, trapping heat and, honestly, reshaping the climate. To restore the natural balance, we must do what nature does, but faster, cleaner, and at an industrial scale. This is where artificial photosynthesis enters the story, our most powerful research and development pathway toward a carbon-neutral world. Our channel, Mission Viksit India, discusses new and innovative ideas in every video to help make India a fully developed nation by 2047. In today's video, we will talk about artificial photosynthesis to end air pollution and the climate crisis. We request you to watch this video till the end and definitely share your thoughts in the comments. Nature solved energy billions of years ago. Plants convert sunlight, water, and carbon dioxide into life. Humanity still hasn't mastered this process artificially. For global energy gap, we must focus. Today's solutions focus on carbon capture, emission reduction, compensation, not creation. Artificial photosynthesis exists only in labs. No nation has adopted it as a core energy strategy. Why artificial photosynthesis is a breakthrough frontier? Because artificial photosynthesis could produce clean fuels, emit oxygen, absorb carbon, power mobility and industry. It is not just green energy, it is regenerative energy. It is indeed India's strategic opportunity because India faces climate pressure, energy demand, import dependence. Artificial photosynthesis could create new fuel industries, position India as climate leader and inventor of oxygen emission engines and vehicle to end climate as well as energy crisis, redefine sustainability economics. The world is just trying to reduce harm, whereas India can build a new source of energy that heals. What is artificial photosynthesis? Artificial photosynthesis uses a synthetic leaf, built with synthetic chlorophyll to convert sunlight, CO2 and water into oxygen and useful fuel. Professor Max Crossley of Sydney University has already invented synthetic chlorophyll. Here's how it works. Sunlight is concentrated on special catalysts or solar reactors. Water splits into hydrogen and oxygen. Hydrogen reacts with captured CO2 to form energy-rich fuels such as methanol, formic acid, or synthetic kerosene. Or CO2 can be split into carbon atoms and oxygen. Oxygen released to the atmosphere, while carbon atoms enter a specially designed combustion chamber to generate clean energy for engines or vehicles to run. It is the same miracle that a tree performs, but guided by science and engineered precision. The R&D blueprint has the following 5 objectives. First, solar thermochemical conversion. Here, we use concentrated sunlight and materials like cerium oxide to split carbon dioxide and water into hydrogen and carbon monoxide, the syngas foundation of clean fuel. The goal is at least 40% thermal efficiency and continuous operation above 1,000 hours. Second, catalytic fuel synthesis. We convert syngas into liquid fuels through Fischer-Tropsch or methanol synthesis. The aim is to develop catalysts that are cheaper, more stable, and highly selective. Our target's solar-to-fuel efficiency of at least 10% and carbon conversion above 90%. Third, reactor integration and energy management. The idea is to design compact modules that harvest heat and light together, recycle waste energy, and operate day and night. The goal is fully self-powered solar fuel units with no external electricity. Fourth, scaling and deployment. We need to move from lab scale, 1 liter per day, to pilot scale at 1,000 liters per day, and then to industrial scale at 1,000 tons per year. The goal is commercial rollout by 2030 to 2035 at cost parity with fossil jet fuel. And finally, fifth, oxygen emission engines and vehicles. The plan is to design engines and vehicle chassis coated with synthetic chlorophyll that can absorb atmospheric carbon dioxide, split it into carbon and oxygen, release oxygen back into the air, and use carbon atoms for carbon fission or carbon fusion-based energy generation in a specially designed combustion chamber. The goal is commercial rollout of oxygen emission engines by 2030 to 2035, enabling India to become the first carbon-neutral nation and a global model for climate healing. The scientific challenge and why it matters: unlike ordinary solar panels that only produce electricity, this technology creates chemical energy. That means fuels that can fly aircraft, power ships, drive heavy industry, run factories without emitting carbon, and actually eat carbon while releasing oxygen to make air pure and healthy. Every advance, a better catalyst, a longer life reactor, a more efficient heliostat, is a step toward global energy freedom. Artificial photosynthesis is not just a climate solution, it's the re-engineering of civilization itself. What is the cost and timeline? For lab R&D by 2026, the cost is about $1 to $2 million, with a milestone of 1 liter per day demonstration. The pilot phase, from 2026 to 2028, will need $5 to $10 million for 1,000 liters per day continuous operation. The industrial demo, from 2028 to 2030, will require $50 million for a 1,000-ton per year methanol plant. Commercial scale after 2035 will need $300 to $500 million to create a carbon-neutral fuel market. What would be global and national objectives? Globally, 3 missions are clear. First, eliminate carbon dioxide from aviation and heavy industry. Second, produce clean fuel locally from sunlight. Third, close the carbon loop by reusing captured carbon dioxide. For India, these goals align perfectly with Viksit 2047 and the National Green Hydrogen Mission. It is India's strategic opportunity. India receives over 5,000 trillion kilowatt-hours of solar energy every year. That's more than 10,000 times our annual power demand. Using even a tiny fraction of this to produce solar fuels could replace billions of liters of imported oil. Our deserts in Rajasthan and Ladakh are ideal for heliostat fields. Our labs, IISC, IITs, CSIR SECRI, BARC, and DICP, already possess world-class capabilities. With an investment of 25,000 crore rupees over 5 years, India can launch 100 solar fuel R&D labs, 20 industrial pilot plants, and 10 mega solar fuel parks. India can become the global capital of carbon-neutral fuels. What is the benefit, and why does the world need it now? Environmental benefits: zero net carbon dioxide emissions. Every liter burned equals a liter captured. No oil drilling, spills, or transport pollution. Cleaner air, greener cities, revived ecosystems. Economic benefits: replace 20% of oil imports and save 2 lakh crore rupees annually. Export synthetic fuels and create a 4 lakh crore rupee global market. Technological benefits: breakthroughs in catalysis, materials science, and AI-controlled reactors. New jobs in solar and carbon dioxide utilization industries. The invention of the oxygen emission engine and vehicle would create global demand and a big market for a new generation engine and vehicle from India. Strategic benefits: energy independence for defense and aviation, and a geopolitical edge as the world's supplier of carbon-neutral fuel. This has deeper meaning, to go from biology to technology. Billions of years ago, cyanobacteria invented photosynthesis and changed Earth forever. Today, we must reinvent photosynthesis to save that same planet. We are not fighting nature. We are learning from nature to heal what we have harmed. Let every university adopt a solar fuel research project. Let every city build a carbon dioxide to fuel demonstration plant. Let every young scientist join this mission. This is our moon mission on Earth. A journey from pollution to purity, from dependence to innovation. The future is bright because the future is solar. Together we can turn sunlight into hope and build a carbon-neutral world by 2047. Mission Viksit India seeks to give India's research and development a new direction, a new speed, and a new courage. Today, we place the need for artificial photosynthesis as a public appeal. Do you believe artificial photosynthesis can become India's next scientific revolution to end the climate crisis? Do you agree that India must urgently launch R&D for artificial photosynthesis to create the oxygen emission engine as a national priority? Should India adopt and start the world's first artificial photosynthesis and oxygen-positive energy systems engineering curriculum to create mastery and a new frontier technology in India for making India first world nation? If you agree, Then send your email to the Union Ministry of Environment and Forest and the Union Ministry of Science and Technology, requesting them to take measures as suggested in this video. You can share the link of this video also. Share your thoughts, share this video, and subscribe for more future science and innovation content. Thank you for watching till the end. Jai Hind, Jai Bharat.